Hi there, we continue with this is chapter 19, and we want to see two sample t-test. And this one is the example, the red blood cell counts in space rats, and the data is in this data file. Later on we will see this data in the Excel. And we want to look at, the question is we want to compare the blood cell counts in flights, rats, and control groups, and the alpha level is in 0.05, and then we also want 95% confidence interval on the difference between these two sets of data. And the solutions, we should first one, we want to check if the near normal condition is met. Later on we will see because each data set contains 14 data, so that's relatively very small groups. So that's the first we check the near normal condition. Let's go to the Excel. I did some pre-calculation, so that's the basically draw the box plots. That's the flight RBC and the control RBC. So each group only have 14 data. And this is the box plots. So box plots looks quite symmetric. So we see it should meet the near normal condition. But we do one more test on probability plots. We didn't use histograms, as you probably see in this figure, because the data set is too small. This one is not really give us a very perfect, like normal distribution figure, because the data set is too small. So we delete this one. It does not really use for small sets of data. And then we do the probability plots. So probability plots, as we talked before, we have the data is exactly the same data from the flights RBC and the control RBC. So these two sets a little bit different from previous. The original data is we sorted these two values. Sorting functions is should be in this in the home tab. There is a sort. Take a look. If I select data, and then it will say sorts from smallest to largest. So we just you just click this one, and then it will sort here. And then we generally write the index I and the probability of PI. And then we only need the two numbers here, give the Excel the trends, what value we want. And then we goes to get every values here. So you can see we have 14 data on each group, and then probability PI. So we count this value, calculate this value. Remember, we use the number value index number minus 0.5, and then divide by the how many in these data sets. So we basically will count how many data here instead of previous one we put only on the column A, but here we use two sets of data all put in column A. So you can see I use A23 to A36, and also put dollar signs. Remember we use F4 to put dollar signs in front of each cell. That means as we do the counting calculation on the following cells, this value does not change. So that's this equation. And then we do the just drag over. So that's give us the probability of this number I. And the next we do the remember we do the probability plots. So we select this group data and combine with this group of data. We use control, select this group, and then we goes to scatter plots. Just use simple scatter plots. And we do so remember we do some modification of this one. Is we first x-axis, so we format x-axis because we want the x values start from 6. So last tab here, axis options, we want the minimum value is 6. So maximum value, it will automatically detect the large number. So that's 10. That's okay. And remember one more thing is once you click once on the figure, this 3 tab will coming out. So we want to see the trend line. So of course we do the change the so this is probability plots of flight RBC. So this figure is basically give us quite near normal, quite close to the central line. That means this data set is meet the near normal condition. And I also did the second group, the control RBC with the probability plots. It's also give us quite meet the near normal condition. And next we do the calculation of the 2-sample t-test. Just go find our templates. So the t-test template contains 3 pages. So that's the first one we did introduce this one in previous the chapter 18, and this is the 2-sample t-test. And the next chapter is a paired t-test. So we use the 2-sample t-test. So in this calculation, so you can see we have the left this area empty. That's the area we need to copy those data. And it goes to our original data is here, flat RBC and control RBC, control C, and then paste it over here, control V. So we get almost calculation down here. That's just we need this one because we need alpha level and the degree of freedom. So degree of freedom, that's the in our calculation later on we'll see it's 25, but it is simple to use. Is n1 plus n2 minus 2. That's basically give us 26. Another way to get a degree of freedom from Excel is we use data analyze tool. So it goes to data analyze tool, and then in this case we see there is a t-test 2-sample assuming equal variance. Later on we will talk about the pooled and unpooled 2-sample t-test. The second one is t-test 2 samples assume unequal variance. So if the question does not specify, we just use the unequal variance. So we click OK. And then we'll look at this one. Let's delete this one, because that's the from the previous example. So that's the first we select the first columns for our first data sets, and the second one put your mouse here, click, and then you choose second column, and then so horizontal. Hypothesis mean difference, we want to check if these two different, just insert 0. First row is label, so click here, and the alpha level 0.05, and output range, so you can choose a new worksheet, but it's not really taking a very big space. We just select this one, and then we click OK. So we go down here a little bit. So this one is you see degree of freedom calculation is equal to 25, but the Excel generate is 26. If you don't want, we don't really ask you to calculate the degree of freedom, so you can just simply insert this value into our templates. So 26. And the alpha level, we already talked about, we want 0.05. Okay. And look at the results. There's some number signs here. That simply means the cell is too small. Just drag this one a little bit bigger. So you can see all the values here. And let's look at the outputs here. So once we get this one, this is just once we put over here the mean value, sample size, mean value, standard deviation is all listed here. You probably see here, I just highlight this range, so get this one. You probably see the variance is here. The mean value is the same, and the variance is this value. If you take a square root of this one, and that's exactly equal to these two values. And the result, so we did do these templates. We did do put and unput calculation in both here. So these two values is the same. Because this one is standard arrows, that's put, standard arrow, unput. These two values is a little bit different, that causing this the denominator. Let's take the denominator is this one, and the denominator is this one, so a little bit different here. And then that's the put p-value and unput p-value. And then we have confidence interval. So look at this one, because in this case we want to see the output value. We don't assume the equal variance, so we use the output value. So we get the t-test value. So t-test value is negative 1.43678. So exactly the same value. And then so this question, we want this one is unequal. So I should insert symbol here is unequal. That means our output p-value we will read is the two-tailed p-value. So 0.162, that's two-tailed 0.1627, that's exactly the same value here. So from the two sample t-test, we don't have confidence interval coming out. That's why our templates provide these results. And you can take a look. The video is almost end. So if you look at back to the this one, we get exactly the same result as in this one, and also confidence interval, same results.